Hello everyone, I am Athar Chauhan and this is part of the presentation. I am going to explain how we normalize a feedback rating value using three important normalization methods: min-max, z-score and decimal scaling. We'll be applying all the methods to specific value which is x equals to 35 from a data set of 27 feedback ratings. Our dataset contains 27 sorted feedback ratings ranging from 13 to 70. The statistical properties of this dataset are: minimum value is 13, maximum value is 70, mean is 30.30, and standard deviation is 12.41, and decimal scaling factor j equals to 2. And the rating we want to normalize is 35. Let's start with min-max normalization. This method converts values into the range 0 to 1 based on the minimum and maximum values of the dataset. Using the formula, the normalized value for 35 comes out to be 0.386. This means that the rating 35 sits at 38.6% of the total spread from the minimum to maximum. Min-max is simple and useful, but it's highly sensitive to outliers. Z-score normalization. Next, we apply Z-score normalization. This method tells us how far a value is from the mean in terms of standard deviations. For our dataset, mean equals to 30.30, standard deviation equals to 12.41. Using the formula, the Z-score for 35 is 0.379. This means rating 35 is 0.379 standard deviations above the mean. Or in simple words, it's slightly above the typical feedback rating. The third method is decimal scaling, the simplest one. We simply shift the decimal point based on largest value in the dataset. Our maximum value is 70, which has two digits. So we set j equals to 2. After applying decimal scaling, the normalized value becomes 0.35. It's fast and easy, but doesn't give deep statistical insights like z-score. Now comparing all three methods. Now let's compare the results. Min-max equals to 0.386, z-score equals to 0.379, and decimal scaling equals to 0.35. All results fall within a similar range, but each method explains something different about the data. Min-max shows the position within the data range. Z-score shows how far it is from the average. Decimal scaling just reduces the magnitude. This was the method evaluation. And why z-score is the best choice? For feedback rating analysis, z-score normalization is the most meaningful method. Here's why. Feedback ratings naturally cluster around an average. Mean and standard deviation give important context. Knowing a value is slightly above or below average is more insightful for decision making. Z-score allows comparisons across different products, departments, or time periods. So in this scenario, Z-score clearly provides the best interpretation. Talking about the key takeaways now. To summarize, our normalized values for x equals to 35 are: for mean max 0.386, for z-score 0.379, and for decimal scaling 0.35. Z-score normalization offers the most meaningful insight because it shows how the rating compares to the overall trend. Always choose your normalization method based on data distribution and goal of your analysis. Context is more important than convenience. I hope you liked my video. Thanks for watching.